PLA designed for annealing with minimal deformation. Well, this is very promising. Let's try it. Hello, welcome back. AzureFilm sent me some filaments for the testing. They have the new Prime line, and I got these boxes for free, but I'm not paid anything about this. Now, I don't really like to accept filaments for the testing which are not available worldwide, but these are so promising that I made the exception. I have here PLA Prime, ASA Prime and ABS Prime. Now ABS and ASA, they have also very interesting specifications, great layer adhesion, and also they are designed to prevent warping, which is good for the printability, but also it is good for the dimensional accuracy, because don't forget, usually this material shrinks, and if you need some precise mechanical parts, this may cause some problems. But in this video, I will test only the PLA Prime. This will be tested in a separate video. About this PLA Prime, if I would look only the specifications and print settings, I wouldn't say this is PLA. It has excellent heat and impact resistance, strong interlayer adhesion, and it has minimal shrinking during the annealing. If you're not familiar with annealing, you can improve the mechanical properties. For example, one of the biggest improvements you will see in temperature resistance from, let's say, 50-55 degrees Celsius. After annealing, it may heat up to temperatures up to far above 100 degrees Celsius, sometimes even 150 degrees Celsius. I tested this earlier on this channel, and the main problem is that it will shrink and deform during this process. And here it says minimal shrinking during the annealing. So we will test this too. About print settings, I have same information on the site and on our box. The nozzle temperature between 230 and 265 degrees Celsius. So I'll try my print settings with 250 degrees Celsius. The bed temperature between 0 and 60 degrees Celsius. It is designed for the fast printing up to 300 millimeters per second. Approximately, I will limit the flow rate to 20 cubic millimeters per second. Nice vacuum packaging with some desiccant inside. The color is light gray. On the sticker, same information like on the box or on the website. A lot of holes to lock end of the filament. Only I'm missing some kind of scale to see how much filament I have approximately. I'll print everything on Bambu Lab X1 carbon. I'm not even sure what material should I give here. I'll try generic PLA, but I have to change the settings in the slicer. And before I start printing my test objects, first I print a small temperature tower just to see the bed adhesion and maybe some other settings. Here the bed temperature was 60 degrees Celsius. The printing is finished. Immediately the bed adhesion check. It could be better. The temperature tower looks great on any element, no stringing even on 250 degrees Celsius, so I print everything on this temperature. Print settings 250 on the nozzle and 65 on the bed. It's printing fast. The max flow rate is 20 cubic milliliters per second in my settings. Last few vertical objects. Printing was finished a few seconds ago. Quick bed adhesion check until it's hot. It's great. Okay, I have to wait until it cools down. And when it cools down, it is very easy to remove the objects. The first group is printed. I will mark them, and I'm reprinting these test objects because the other group will be annealed. The second group is printed too. The bed already cooled down, mostly. And I can move to the annealing. I'm preheating the oven to 120 degrees Celsius, and just in case, the temperature I follow with this thermometer. When the oven will be preheated, I will insert the test objects, and they are in the position as they were printed. I have to wait until the temperature stabilized. As you can see, it overshot the set temperature by 20 degrees Celsius until it stabilized later, because the oven is designed for 200 degrees Celsius and similar, and you have to pay attention to this, especially if you want to use the oven for the drying. The timer is set to 1 hour. And when the heating turns off, I will leave the test objects to cool down together with the oven. After 20 minutes, I can see that the temperature stabilizes around 115 degrees Celsius, but even now I can see some warping on some test objects, but I will leave the annealing to be finished and I will analyze the objects later. I left them overnight to cool down. They look okay. So these are annealed and this is the reference group, and only on two objects I can see just slightly more warping. That's this one for the bending test and this one for the impact test, but it's not big, and actually all others are quite usable. Let's check few dimensions. This one is to see the shrinking in the X, Y and Z direction. 2997, 30.04, and in that direction 2972. Okay, this is very good. This is very promising, just a little bit warping on two test objects, but others are in great shape, and actually there is no big difference in the dimension. Tensile test with horizontally printed objects, and here you can see the average values for one group. This is the layer adhesion test with the vertically printed test objects. And now this is printed vertically, but with the 20% infill and two walls. And here you can see again the average values. I was thinking a lot about this weaker layer adhesion because I experienced this after every annealing I did so far. And first I thought that these test objects are warped a little bit, and beside that tensile stress we have some bending stress too. But I think this is something different. We still have that warping, but this warping is some micro warping between the layers. And if there is some delamination, deformation, it may be a little bit weaker. And the layer adhesion is like a chain. It is strong as the weakest chain link inside. And just a slightly weaker layer, and we have that weaker layer adhesion in the test. Two-sided Shear test with horizontally printed test object, side by side. And the annealed version was slightly stronger, but the difference is not big, and even after the break they look very similar. And now with the vertically printed test objects, so the layer adhesion is important here. And again we can see that the annealed version has a slightly weaker layer adhesion. After the test they look similar, and one part is missing, I couldn't find it. Torque or twist test with horizontally and vertically printed test objects. I'm starting with horizontally printed. This is the loaded 90-degree rotation. And then you will see with the regular I could make 1.5 rotations, but the annealed version broke after one turn. And here you can see this is the regular and this is the annealed version. And then these are objects printed in vertical position, so again the layer adhesion is important here, but they broke on very similar load on 1.2 Newton meters. And now 3-point bending test. Here you can see where all loads are placed, but I will place them one by one, and I will measure the deformation after 1, 30 and 60 seconds. And this is speed up time-lapse video, and the numbers I will show you in results part. This is the deformation under 5 kg load, and this is under 10 kilograms, and you can see that they are constantly deforming. And after this test, well, the annealed version had some warping already, but in both cases we can see some deformation. The temperature test in the oven, where I want to record the temperature of the first deformation. And I believe that this is very important experiment for this material, because this may be one of the main reasons why would you like to do this annealing. And the regular PLA started to deform at around 70 degrees Celsius, which is basically the PETG temperature, and after this it deformed very slowly. But the annealed version started to deform at 161 degrees Celsius, and I stopped the experiment on 180 degrees Celsius, and of course on this temperature both materials were equally soft. But this is very impressive. The impact test to see if the annealed version is a tougher material. Still on my DIY testing machine, because my new from the eBay is not prepared yet. It needs some adjustments. Reference PLA. Oh, annealed version. Zero position. Even without annealing, it looks like very tough material. In this case, after annealing, the material became a little bit more brittle, but in both cases these are very tough materials compared to many other filament types. The creep test, the deformation under the constant load, which will be 1.25 kilograms, and I'm measuring the distance between two reference surfaces. 14-16, similar deformation. They had similar initial deformation, but only after one day I can see 1 mm more deformation on regular version. I measured them every day, and now on the fifth, the last one, I can see less deformation on annealed version compared to the regular. 17-11, 15-15. And now let's remove the load. And we can see less deformation on annealed version, and I believe that this difference would be even bigger if the temperature would be higher. It's time to analyze the results, and this time two lines will be added to the summary table for my Patreon supporters. There will be a reference material and also the annealed version. Let's start with the creep test, and here we can see on this graph the values, distance between two reference surfaces, We can see that they have similar initial deformation, but later the reference material had bigger creeping and more deformation. But this we can see on the second graph, where we can see the difference between 2 days. And we can see on the day 2 that creeping stabilized, but it was presented continuously, but it was significantly smaller with the annealed version. And don't forget, this was on 25 degrees Celsius only. On a tensile test, no big difference. The reference material was slightly stronger, but on a layer adhesion, we can see that the annealed version is weaker, and we can see this on that object which has 2 volts and 20% infill. And what is the reason for this, I explained earlier. On a shear stress, this is the horizontally printed objects. We can see the annealed version is a little bit stronger. On the vertically printed objects, again we can see that the weakness in the layer adhesion with annealed version. On a 3-point bending test, here we can see the deformations under these loads after 30 seconds, but maybe more interesting is this, where we can see the deformations under these loads after 130 and 60 seconds. And here we can see similar initial deformation, but later when we go with the higher loads, we can see not only more deformation with the reference material, but also that creeping, so it constantly deforms under that bigger load. On a torque or twist test, well, with the horizontally printed objects, I measure both, but more important is the load at 90-degree rotation. Here the annealed version was slightly stronger, but don't forget, with that I could make only 1 turn, with the reference 1.5 rotations. Now with the vertically printed test objects, where the layer adhesion is important, well, I don't have measurable difference here. Maybe the annealed version is a little bit weaker, but I couldn't measure any difference with my equipment. On the impact test, no big difference. The annealed version was slightly brittle, but both are very tough materials compared to any other type. And on a temperature test, this is also very important for this material. As you can see with annealing, in my case it started with deformation at 161 degrees Celsius, which is extremely impressive. But this is also very good. I mean, the base material started with deformation at approximately 70 degrees Celsius. Usually PLA starts between 50 and 55 degrees Celsius. Another big work is finished, and yes, very interesting material. It can be annealed without any bigger shrinking or deformation, and from this aspect it is better compared to any other PLA I tested so far. But it is still not perfect. Some mechanical properties are improved, but some of them not. For example, we will get a stiffer material, but on the other side we have a little bit weaker layer adhesion. I think 2 most important reasons why we want to invest energy into this annealing. The first one is the temperature resistance, huge difference we have here, but on the other side is the creeping. Don't forget, I did my creep test on 25 degrees Celsius, but if it would be 35-40 degrees Celsius, the object will be outside or in a car on a hot summer day, that difference will be much bigger. I'm very curious about their ABS and ASA Prime line with that zero warping property. I hope you will follow me to that video too, and don't forget to subscribe and enable that notification bell button too, because in most cases the notification is not sent to my regular subscribers. Not sure about the reason, and it's not that this is a type of the video, because I can see very similar sized channels, but when they publish similar video it has much more views. So I'm not really sure what is the problem with my channel. Slowly I get used to it, but without any Patreon supporters I think this channel would slowly die. Thank you for watching and happy printing!